Okay, welcome guys. Today we'll deal with the heat. I think it's part 6. We'll deal with an experiment today. The experiment is based on a specific heat of solid. What? Specific heat of solid now. Okay. So moving to this experiment, we require some apparatus. Okay, majorly specific heat of solid, right? In this case, if you consider the aim, right, we are going to measure specific heat of the solid. Okay, in this experiment, we'll take solid as a lead shots now. Which things? Lead shots. Okay, so coming to the apparatus that were required here is very simple. One is major important thing is calorimeter. Okay, it looks like this now. So suppose it is inserted inside a wooden box. Okay, let's consider this a wooden box. It is inserted inside a like structure like this. Okay, this thing we'll call it as a calorimeter, but inside to this wooden box and to the calorimeter, in between something is present. That is nothing but a cotton balls. Okay, cotton balls were inserted in between these two. That's because what happens is, if this is going to touch this wooden box, there might be heat transfer takes place from between these two also, right? So to eradicate this, what they did was they put some cotton balls inside this, right? Now, and also 2 holes are present on the top. Okay, how many holes? 2 holes, right? So we'll deal with it in the experiment. Okay, we need a calorimeter, a laboratory thermometer. Okay, laboratory thermometer is much longer than compared to the normal thermometer. Okay, so this thermometer is used in laboratories because laboratory thermometer is different rather than the clinical thermometer, right? So it doesn't have a king, so it shows accurate temperature when it is inserted inside the liquid. Okay, so laboratory thermometer might get used now, and along with this we'll take a solid substance that is nothing but a lead shots. What? Lead shots. Let's say the shots might be like this. Okay, we'll take some crystals like this, right? Small pieces of lead shots, and along with this we'll take some amount of water. Okay, that has been taken in water bath. Water bath is nothing but a, okay, it is also a bowl now. Okay, water bath, right? The bowl in scientific terms will say it like a water bath, right? And we will take some amount of water also. So to heat the water, we'll take a Bunsen burner, right? Along with this, we'll take weighing machine also. What? We'll take weighing machine. Wonderful. So let's go to the activity now. Firstly, okay, we'll take the water bath. Okay, we'll take the water bath and we'll add some amount of water to it. Okay, and we start heating it, and inside this we'll put some amount of lead shots also, right? And you need to wait until it reaches up to 100 degrees centigrade. Okay, we'll get to know the water get 100 degrees centigrade by using this laboratory thermometer, right? So, and before it gets heated, you need to keep moving on and keep the arrangements ready with the this calorimeter might be, right? So it should be inserted. So in the first case, what we do was we'll put all these cotton balls here. Okay, wonderful. All these cotton balls are put, and inside we'll take some amount of water, that to 1/3 level of water. What? 1/3 level of the water might get inserted inside this calorimeter, and after this lead shots get 100 degrees centigrade, what we do is just simply open the door of that wooden box and simply insert those lead shots inside. Okay, and within a fraction of seconds, just close the door. Okay, now as I said before, it has 2 holes, right? In one hole we'll put thermometer, okay, that laboratory thermometer, and in another hole we'll put stirrer. Okay, stirrer might look like this. Okay, it looks like a spoon or something else, right? stirrer. Now what we do is little bit, okay, after this water is at initial temperature, right, that is like 28 degrees centigrade maybe, right, and we inserted lead shots, right, we mix them, right. Now we are going to stir the liquid, and after some time what happens is the heat energy that is gained by these lead shots get released inside, because there is a thermal equilibrium happens between the water and the lead shots, yes or no. And then what happens is we tend to see the accurate results here, because if we do the same experiment on a table or something, right, then what happens is the lead shots gets okay, let's say we are doing the same experiment on the table. Now what happens is this is the water and this is the thermometer and this is the stirrer, right. Now we have put all this and this is at 100, let's say this is at 28 degrees centigrade. Now in this case what happens is water is in thermal equilibrium with calorimeter, and this calorimeter is in thermal equilibrium with table, right. So that temperature is being shared by 1, 2, 3 objects now, right. But in this case only 2 objects, that is calorimeter along with the water only sharing, because those cotton balls doesn't allow heat to pass through that wooden box, clear. That is the reason we have taken that wooden box, okay. So that is the reason we just dealt with this specific heat of solid based on this calorimeter, right. Okay, so to get the accurate results we will do this, right. Now that was the small experiment, okay. Experiment was very simple, but we need to do some calculation purpose, right. So to do the calculations you need to derive the formula for specific heat of a solid, right. So let's do this. We'll take water, okay. Firstly we'll consider calorimeter, okay. That calorimeter will consider that temperature as small m, right. Not the temperature, weight of the calorimeter, okay. When we put that calorimeter on the weighing machine, what happens is we'll get the mass. The mass of the calorimeter is m, okay. Let's consider like this. Now we'll add stirrer to it. Now calorimeter plus stirrer, right. I mean in this case we got calorimeter along with the stirrer, right. So we'll get a new weight, right, and we'll consider that weight as m1, and then we'll add some amount of water to it also, calorimeter along with the stirrer and some amount of water, right. So we are going to add some amount of water to it. Now in this case we are add water and we'll consider it as m2. Now if you find these two, there is only one difference, that is nothing but only water, right. So in this case, to find mass of water is equal to, we need to subtract from this to that, right, we will get a final value, right. So we simply subtract m2 minus m1, is it clear. So this is very important, okay. We will use this thing in the formula, and calorimeter mass also important, we will use that also, and then we will add calorimeter, stirrer, and we have water also here, right, and along with this we will add some amount of lead shots, yes or no, right. Looks like that. Calorimeter, water, stirrer along with some lead shots, right. If we weigh them we will get some weight again, right. We will consider that weight as m3, yes. Now to find mass of lead shots, only lead shots mass, okay, mass of lead shots, we will simply subtract m3 minus m2, right. So this is also very important, you need to remember this thing also, right. So we are gathering all this because we have a formula, that is Q is equal to ms delta T, yes or no, right. So from based on principle of method of mixtures, what principle of method of mixtures, you know this, right. That is nothing but net heat lost by hot body. Here hot body is lead shots, is the hot body, it just lost its heat energy, and that heat energy is being gained by, so principle of method of mixture says what, net heat lost by hot body is equal to net heat gained by cold body, that heat energy gained by the calorimeter along with the water, right. These two gain the temperature that is released by these lead shots, right. So we are going to add them all and we'll get the final value. So let's see here, in this case we have mass of lead shots is m3 minus m2, okay, wonderful. Now I think Q has a formula, that is ms delta T is equals to ms delta T plus ms delta t, right? So I simply written like this. Now if you look here, let me tell you one thing, that is m, okay, simply for specific heats, I just simply put specific heat of lead shots as SL, okay, specific heat of a calorimeter as SW, and specific heat of water as SW, right? So let's substitute them. It looks like this: m SW into delta T is equals to, yeah, m specific heat of calorimeter is SC into delta T plus m SW into delta T. I think we'll get it right. Now coming to the masses, okay, we just calculated the masses right now, right? So specific here lead shots represents mass of lead shots is m3 minus m2 into SW into delta T is equals to m is the mass of calorimeter, so no need to worry here, msc into delta T plus, but water's mass value is m2 minus m1, let's do like this, m2 minus m1 into SW into delta T. Wonderful, okay. Now everything is finished, but what about delta T here, right? Right? So now let's say, let me tell you one thing here. So while dealing with delta T's, okay, we'll do something. So lead shots temperature might be considered as T1, okay, lead shots temperature temperature is considered as T1, okay, and here msc into delta T, right? So here temperature of water, that too at initial temperature of water when it is inside this, right, we'll consider it as T2, and finally we have, okay, let's consider lead shots temperature T1 is nothing but 100 degrees centigrade, right? So T2 is at initial temperature 28 degrees centigrade, and after they both mix it together, right, and after they both mix it together, what happens is water plus calorimeter, right? So we are dealing with this because they both were in thermal equilibrium, so the temperature is T2, wonderful, and after they mix it together, we'll got our thermal equilibrium temperature, that is nothing but T, okay, we consider as T, right? Let's substitute the values now. Now in this case, firstly we'll deal with lead shots, okay, lead shots is present in T1, it is also present in T. After they both get intermixed with each other, what happens is 100 plus 128 is 128, 128 by 2 is 64 degrees centigrade, right? Now while dealing with lead shots temperature, we are going to separate them by these two, because lead shots are present here, okay, lead shots are present here also, right? We are going to, by the difference, m3 minus m2 into SW, in place of delta T I am going to write like this, that is T1 minus T is equals, here in this case MSC into, in place of water and temperature, these two were, right? So we are going to write the relation between these two, because water is present here and water is also present here, right? Initial water, right? So higher temperature is T and lower temperature is T2, so T minus T2, as calorimeter and this water both share the same temperature, right? That is the reason I am going to write like this, plus m2 minus m1 into SW into, in place of delta T I am going to put the same value because they both share the same temperature, right? Now in this case I am going to, because these two were common here, okay, let's common them, T minus T2 into MSC, what, MSC plus m2 minus m1 into SW, right? So in this case you want specific heat of, I just written SL here, right, because specific heat of lead shots is SL, right? So this is also SL and SL, okay. So now specific heat of lead shots, you need to find it out, right? Now in this case this thing and this thing both were multiplying this, right? Now I am going to send those two to the other side. Now what happens is it becomes m3 minus m2 into T1 minus T, right? So this is the required formula for specific heat of a solid. Here let me tell you a little bit interesting thing, that is I just consider the values based on my regardings, Nana, right? Your book might contains a different values or different way, maybe, right? See, answer is same, okay, but I considered some values differently, right? So that is the reason I got the answer like this, okay. Don't think it is a wrong answer, it is a right answer, okay. but I consider different values here. Okay, some persons might consider it as T2 and some persons might consider it as T1. Okay, there might be differences happens. Okay, so there might be differences happens, but here the major thing concept is same. Okay, your book might contain different values, but the concept is same. Okay, so just be focused and listen. I think this is the final act, this is the activity of a specific kit of a solid. Okay, so tomorrow or okay in next class we'll deal with final conclusions, right, and also activities. Okay, that's it. Thank you.